Hello, I'm Andre. Welcome to a new episode. Don't memorize trigonometric functions because there's actually a much easy way to calculate them using right triangles and following a few simple steps and knowing some simple rules about the right triangles. So maybe you know from school that for some maths problem you need to memorize, for example, what's the sine of 30 degrees. But mathematics is not about memorizing things, and there's a much simple way, because memorizing these things is just a waste of energy and of time. Maybe you have a table from school that where you have 0 degrees and then 30, 45, 60, 90, and you have the sine and the cosine, and everywhere you have fractions, so fraction, and every time at the bottom you have 2, so we write a bunch of 2's, and then we have 0, 1, 2, 3, 4, that's very simple, and then the same thing but in reverse, so 0, 1, 2, 3, 4. And actually we square root the number that's at the top. So that's it. That's about the table. And if you want to know the tangent, that's the sine over the cosine, and the cotangent is the reverse, the cosine over the sine, and that's the same thing as saying that the cotangent is 1 over the tangent. But you can easily make mistakes by memorizing this, because you usually don't write it down in a test because you don't have really that much time. And also writing this table, you can make mistakes because maybe you are concentrated at your exercise, and by mistake you just replace the sine by the cosine and the cosine by the sine, and that will mess up your results. And maybe you forget something. You forget that you need to take the square root here up, or something else. So I'll show you what's and this is also kind of cheating, because you don't actually calculate that. It's just a table that happens to be true. So I still don't blame that table. This table is very good and it's pretty fun to play with it, but I will show you how to actually calculate this. So let's start from the middle. We have 45 degrees. What if we want to know the sine of 45? So we simply draw a right triangle that has also a 45 degrees angle, and we know that the sum in a the sum of the angles in every triangle is 180 degrees, and I will explain that in another video. So this has 45, and from 180 degrees all that we have left are also 45 degrees, and that means that these two sides are equal in length. And now give a simple length to one of the sides, 1. Now we know that these two are equal, so the other will be also 1. And this one, we can calculate the length using the Pythagoras Theorem that tells us that in every right triangle with the sides A, B and the hypotenuse C, a squared plus b squared is equal to c squared. So we take the square root of this whole equation, and we know that c is equal to the square root of the sums of the squares of the other two sides, so the square root of a squared plus b squared. That means that this side is the square root of 1 squared plus 1 squared. 1 squared is 1, so that's the square root of 1 plus 1, and that's the square root of 2. This side is the square root of 2. And now we can calculate our trigonometric functions. So you need to know that sine. So what sine of 45? Sine is the opposite side over the hypotenuse, and that's 1 over the square root of 2. So that's sine of 45 degrees. Maybe you notice that this is not exactly what our table says, because our table tells us that the sine of 45 is the square root of 2 over 2, and we calculated 1 over the square root of 2, but that's the same thing, because if we rationalize this by multiplying both sides with the same number, the square root of 2, we still have the same proportions, so the number will be the same, the result. So if we rationalize this fraction, we'll actually get the square root of 2 times 1 is the square root of 2 over the square root of 2 times the square root of 2 is 2. And we get the final result that is in the table. Then we can calculate cosine of 45 degrees, but actually it's the same as you can see in the table, because cosine is the closest side to the angle except for the hypotenuse and over the hypotenuse. So but this side is also 1, so we will have still 1 over the square root of 2, and that's the square root of 2 over 2. So the results are the same. Then the tangent, we could also make this over this one, and that's 1 because these are the same things. But we can also calculate without knowing what's the sine or the cosine. We can calculate that much easier. So the tangent of 45, maybe no, that's 1 because this is a beautiful result. So the tangent of the 45 degrees is the opposite side over the closest side except for the hypotenuse. And that's 1 over 1, which is 1. And the cotangent is 1 over the tangent, and that's 1 over 1 is still 1. Or, without knowing what the tangent is, the cotangent is the closest side except for the hypotenuse over the opposite side. That's still 1 over 1, so 1. And the same with any other angle. So let me show you what's 30 and 60 degrees, because if you have a right triangle that has 30 degrees, you will also have a 60 degree angle. So let me draw that right triangle for you. Right triangle, here we have 30 degrees, here we have 60 degrees. Then name the opposite side of the 30 degrees angle. Give it the length 1. Maybe you know that if we have a right triangle with an angle of 30 degrees, the opposite side of that angle of 30 degrees is half the length of the hypotenuse. So the hypotenuse will be twice as big as this angle, so 2. And the other side can be calculated using the Pythagoras Theorem. So we know that this side is, if we take the square root of this side, sorry, not the square, if we take the square of this side, add it to the square of this side, and take the square root, we get this side, so 2. And that means that this side is equal to the following equation. So we square this side, then we subtract from it the square of this, and we get this one. Do you get it? So this side is this squared minus this squared. We subtract the square of this from the square of this longer side. And this means that this is equal to the square root of 2 squared minus 1 squared. 2 squared, 1 squared. And that's equal to the square root of, so 2 squared is 4, and 1 squared is 1. So 4 minus 1, and that's the square root of 3. So this side is the square root of 3. And from now we can calculate our trigonometric functions for both 30 and 60 degrees. Sine of 30 is the opposite side over the hypotenuse, which is 1/2. So 1 over 2, 1/2. Cosine of 30 is the closest side except for the hypotenuse over the hypotenuse. So the square root of 3 over 2. We can see that our answers coincide with what our tables tells us. So the tangent of 30 degrees is the opposite side over the closest side except for the hypotenuse. That's 1 over the square root of 3. So 1 over the square root of 3, maybe you want to rationalize that, so we multiply both sides by the square root of 3, and that's the square root of 3 over 3. Okay. And now the cotangent of 30 is this closest side over the opposite side, so the square root of 3 over 1, that's simply the square root of 3. Now sine of 60 degrees is the opposite side over the hypotenuse, so the square root of 3 over 2. Cosine of 60 is the closest side except for the hypotenuse over the hypotenuse, which is 1/2. Tangent of 60 degrees is the opposite side over the closest except for the hypotenuse, which is the square root of 3 over 1, which is the square root of 3. And the cotangent is this over this, so 1 over the square root of 3, and that's the square root of 3 over 3, so the inverse of this. So now we have all the results, and we are still left with 0 and 90, so I will show this at the final of this video, so right now, because that's a little bit trickier, because in this kind of triangle one of the sides will be 0, and that triangle will be just a line. So if we have a right triangle like this, let's draw one of the angles 0 degrees. So this is one side, like this, and then the other side is like this because it's an angle of 0 degrees, and then 90 degrees down, and we are here. This is our triangle, it's flat. Now don't be confused, this is a triangle, but this angle here it has 0 degrees, and here it has two angles that have 90 degrees. Each angle has 90 degrees. So imagine this triangle like this, like being a normal right triangle, but this side it has the length 0. So if it has the length 0, it's a line like this, and this angle becomes 0, and this it's larger and larger until it's a right angle. It's 90 degrees, and this is 90 too. I mean, it's still 90, it's not 92, it's 92. So how can we calculate this? Just draw a triangle like this. That's not a line because that will confuse you probably, and just draw a normal right triangle, and notice, put this side 0, so this is 0, and you need to know that this angle is also right, and this is 0 degrees, a 0 degree angle. You need to know that. So if we write this, now we can calculate. So give the other side, this side, the length 1. And what's the hypotenuse? We use the Pythagoras Theorem, so we have 0 squared plus 1 squared, that's 1, and we take the square root. The square root of 1 is still 1, so this side is 1. And now we can calculate. So I will write that down. So sine of 0 degrees is actually the opposite side of the 0 degree angle over the hypotenuse. That's 0 over 1, and 0 over 1 is 0. And we can still see that in our table. Oh, okay, we see the square root of 0 over 2, but that's still 0 because the square root of 0 is 0, 0 over 2 is 0, so the result is the same. Cosine of 0 degrees is this over this, which is 1 over 1, which is 1. So that's why our cosine of 0 is the square root of 4 over 2, which is 2 over 2, which is 1. Now the tangent of 0 is this over this, which is 0 over 1, which is 0. The cotangent, actually be very careful here. So the tangent here is 0 over 1. But the cotangent is this over this, which is 1 over 0. So this is actually undefined. We can write it as infinity or undefined. This is not defined because at this angle we can't define the value for the cotangent, and also for tangent for 90 degrees. Sine of 90 is this over this, which is 1 over 1, which is 1. Cosine of 90 is this over this, which is 0. Tangent of 90 is this over this, which is 1 over 0, so infinity, undefined. And the cotangent is this over this, which is 1. So this is how you calculate. And of course this video is over 16 minutes long, but if you are used to this, or you don't need to be used to this, you just need to follow some simple rules of the right triangles. And actually I calculated all the possible trigonometrical functions of sine, cosine, tangent and cotangent, and every combination of these trigonometric functions and all these degrees, number of degrees, so 0, 30, 45, 60 and 90. But in a problem, at a certain point you need to calculate just one of these, so you don't need to calculate something else, just one, and that will take you no time. For example, let's recap. What's the I don't know, the tangent of 60 degrees? What's the tangent of 60 degrees? So we first draw a right triangle that has an angle of 60 degrees. From this we know that this will be 30 degrees, and we take this side, we put it to the length 1, and we know that this side is the opposite side of the 30-degree angle, and that means that is half the length of the hypotenuse. So the hypotenuse is twice this, and this is 2. And this one from the Pythagoras Theorem is the square root of 2 squared minus 1 squared. That's the square root of 4 minus 1, the square root of 3. So the tangent is the opposite side of that 60 degrees over the closest side except for the hypotenuse. That's the square root of 3 over 1. That's exactly the square root of 3. And actually you will do this faster because you won't need to talk. You will just do this in your mind. And we can check that by using our table, because we have sine of 60 over cosine of 60. That's the square root of 3 over 2 over 1 over 2. And that's the square root of 3 over 2 times 2. And that's the square root of 3. So our answer is correct. And you don't need to memorize anything. You just calculate it by this. So if you find this video confusing, please watch it again, and I hope this helps you. So this is what I wanted to tell you. You don't need to memorize any of these tables or results. You just need to calculate that, and that's the beautiful part, the easy part. It's much easier to just following these rules, and that's it. I hope this video helps you, and we will see you now in my next video. Bye.